Hi class, so there's just one worksheet for chapter 4 titled Percentages Worksheet. So this worksheet will walk you through pretty much all the material in 4.1 through 4.4. But before I get started on the percent worksheet, one thing I want to point out is we do have the definition of a percentage at the top here. Right, so here. So it tells us the percentage is a ratio where the second quantity has been scaled to 100. Right? So x to 100. The first quantity is said to be x percent of the second. Percentages are sometimes referred to as rates because they are per 100. Right? So the word percent actually comes from a Latin phrase percentum, right? Which literally means per 100. Right? So whenever we talk about a percent, we're always comparing to 100. Right? So a lot of times you might see, when you work with percents, a lot of people will refer to as setting it up as a proportion, right? Where you have your amount compared to your base, and this is equal to your percent over 100, right? So the second quantity, the base, is scaled to 100 then, right? So the base, the second quantity, is the quantity that you want to be like the whole amount, right? 100% of the amount, right? So you've probably seen this before, right? But one thing that I do want to emphasize is the difference between a percent and percentage points. So percentage points, right? Let me make that a little better. Right, so let's go through an example, right? So let's say you got a 90 on a test, right? So a 90%. In other words, 90 out of 100. Let's look at scenario 1. So in the scenario 1, let's say that you get plus 5 percentage points, right? Well, this literally means that we have a 90% and I just add 5%, right, and get 95%. So the percentage points means I'm increasing by adding like 5 out of 100, right, 5 percentage points. Where a second scenario is, let's say that you add 5%, right? So adding 5% to the 90% is a little different, right? What you would need to do is take 90 times 0.05, right? Where 0.05 is a percent. You can see what this gives you, right? So let me pull up my calculator. So if we take 90 times 0.05, we get 4.5, right? 4.5. So this is how many points would be added, right? So you'd end up having 90 plus 4.5, which is 94.5%, right, on the test, right? So you can see how these two differ, right? So it's because this 5%, right, how much points we're actually adding is 5% of what we started with, right, by how that's worded. So when we add 5% to something, we calculate 5% of what our base is, what we have, and then we add those together, right? Or when we say add 5 percentage points, it means literally just add 5%, right? So you want to make sure that you understand that difference. So this worksheet looks at some labor data, right? So this data is from the Bureau of Labor Statistics, right? The U.S. Department of Labor Employment Situation news release, right? So this website is where a lot of this data came from, right? So we do have some charts here. So we have unemployment rates, and notice it says the word seasonally adjusted, right? So when we seasonally adjust this, there's a statistical technique that's done to the data just to kind of account for some jobs that have like unemployment seasons every season. So an example of this would be like construction, right? So for example, my uncle works construction, and every winter he always gets laid off, right? There's always not enough work to keep him busy in the winter because of the nature of his job, right? So technically he, is unemployed during that time off. But he does make, plenty of money during the year to support him during that time he's laid off. Um, so we seasonally adjust for that, meaning that we don't want to include those people necessarily in our data because that could skew our results, right? So there's a complicated statistical process done to adjust for that. And then here we have non-farm payroll, right? And this is also seasonally adjusted, right? So we have these two tables. So number one tells us the U.S. civilian non-institutional population was 249 million. How big was the labor force in December 2014, and how many people were employed, right? So this non-institutional population, right? These are people that are not in prison or in the military, right? Those are the two big institutional items that are pulled out of the numbers of the data set. And that's because we don't want to count those people as unemployed, right? Because if someone is institutionalized, like in prison, they're not able to be employed, right? So it's not a real accurate predictor of of how our labor force is doing, right? So economists pull those numbers out. So we're also given this chart here. It says share of civilian non-institutional population, right? So we have 59.2% employed, and 62.7% we consider our labor force. Right. So it asks us, well, in December of 2014, how many people were employed? Right. So all right. So I did miss a part right here. So there's actually a first part of the question, right? It says how big was the labor force in December 2014 and how many people were employed, right? So we kind of have two parts, right? Part A and Part B. So to figure out Part A, which is how big was the labor force, right? Well, if we know that there was a total 249 million population, and 59.2% of them were employed, right? I can just multiply this together, right? 59.2% of 249 million is going to be the total number of people that are in the labor force, right? So essentially, if you think of like a circle graph, right, and let this part be 59.2%, I'm after this amount, right? What amount goes with this, right? All the way around is 249 million, so I just need to find what's 59.2% of that, right? So if I take 0.592 times 249 million, right? This gives me, right, so 0.592 times 249. Right, so I get 147 million, and then 408, and then 3 zeros, right? So 147,408,000. This is how many people actually, this would be how many people are employed, right? I used the 59.2 number. So let me fix this up here, right? This would be employed figure, right? So notice I use 59.2%, which goes with employed, right? So so then the second part would be looking at, well, what's the labor force look like, right? Well, the labor force accounts for 62.7%, of the 249 million. Right? So if we multiply those together, you will get 156,123,000. Right? So that would be, this would be how many workers there are plus unemployed. So workers plus unemployed. Right? So we found both of those values, right? So I end up changing this. I end up calculating this number first. Right? So this is like my part A, and this is my part B. Right? Alright, so then continuing along, number 2, it says what percentage of the U.S. civilian non-institutional population was employed in December 2013? Right? So if I take a moment to look up here for my employed, right? So we want to look at this row, right? Then what you should notice is the 1 year change. Right? Here. So between December 2013 and December 14, we went up 0.6 percentage points, right? That's the 1 year change. So you can see this diagram is here to prompt us to think in this fashion, right? So we had some percentage in 2013, that's my original amount, and then I got to 2014, which is my new amount, which is provided in this table. And the 1 year change is we added 0.6 points, right? This isn't percent, this is percentage points, right? So in other words, x plus 0.6 equals 59.2, right? So we're just thinking about them as percentage points. So if I subtract 0.6 from both sides, we'll get x equals 58.6, right? So 58.6 was the percentage employed in December 2013, right? So December 2013, right? So we're able to find that from the chart, right? So number 3 looks at hidden unemployment, right? And this is a growing issue in the United States, right? So hidden unemployment are those that might be working part-time, so they're not able, but they're wanting to work full-time, so they're not able to find enough work, or maybe you want a job, but you can't find one, right? That's called a discouraged worker. Maybe you just gave up, right? So here we have a table. So we have 6.8, 3.0. Here's my 1 month change and my 1 year change, right? So what it asks us for is how many people in December 2014 were working part-time but looking for full-time work, right? So I'm looking at this first row. Right? So notice here it does say in millions. So this isn't a trick question, right? It's telling us that this number is in millions. So if we look at the table, it's 6.8 million. Right? So just making sure that you can read the table okay, right? This question. And then part 4 says use the following formulas to determine how many people currently want a job in December 2014, November 14, and December 2013, right? So if we look at above on the chart, we have people who currently want a job, right? And we have information for December of 2014, right? So this is of 2014. So since I have a 1 month change and a 1 year change, then that's how I'm able to find November 14 and December 13, right? So these two formulas can come in handy. So we have percent change is equal to the total change divided by the original, right? And if we tweak these formulas a little bit, we can also come up with these, which is just the same equation, right? All of these are related, right? So then this part, this is called a multiplier. Right? So this is helpful with percents. So for example, let's say we had a tax of 7% and you wanted to buy something that cost, oops, let's just say $100, right? Something easy. So when you buy something that has a tax, that's a percent increase, right? So so originally we would pay 100% of the price, right? The $100, but then I need to add in 7%, which is the tax. So I end up paying 107%. So the multiplier here would be 1.07, right? So if I take 1.07 times 100, this is the total amount I would pay, which is $107, right? So here's using a multiplier, right? So if you have an increase, your multiplier should be over 1, and a decrease is where your multiplier would be under 1, right? So like if I had a 20% discount on something, right, then my multiplier would be 100% minus 20%, so I'd end up paying 80%, so my multiplier would be 0.8, right? So if I take 0.8 times the price of something, that would correlate with a 20% discount, right? So just trying to relate that to what we already know, right? So this first part, so one thing we just need to note is that so in December of 14, we have 3.0 million looking for people wanted jobs, right? 3.0 million people wanted jobs. So that's just taking that directly from the table, right? This 3.0 number is also in millions, right? It says in millions. So then, so here we're trying to figure out the 1 year change, right? Using the 1 year change number. So this plus 69% came directly from the table also, right? So we have this, or excuse me, this is for the 1 month change, right? So we have November of 14 and 12/14, which is the new amount, right? And this number, right, if we look up at the table, this is the 1 month, right? Right here, plus 6.9. So going in between of November 14 to December 14, we went up 6.9%, right? So we can try to figure this out. So if you think about this in terms of the multiplier, right? I had some x value, and then I multiplied by some factor here to get my new percentage, right? Right, my new value. So we were told for December 14, 3 million, right? So here I'm just going to put 3.0, but we just need to understand that this x will be in millions, right? Since this is also in millions. So I need to figure out what goes here in this green, right? So we can figure that out, right? So if I originally had just a 100% increase, right, that means that I wouldn't have any change, right, and no change. But since I went up plus 6.9%, right, if I add those together, I get 106.9%. So this correlates to a factor, right, a multiplier of 1.069, right? So converting that into decimal form, right, we just move 2 spots to the left, right? So 1.09, 1.069. So then if I solve this equation, right, I'd want to divide both sides by 1.069. And this gives me x equals, so 3 divided by 1.069 gives me roughly 2.81 if we round to 2 decimal places, right? 2.81, and this is in million, right? So 2.81 million people we're in November 14, right? So if we go to the next page, here's where we're looking for the 1 year change, right? So December of 2013 to December of 14, right? And here our data, our table told us that it went down 10.3%, right? So we can do this very similar, right? So again, I have some X value, right, that I don't know, some population of people that wanted a job in December of 2013, and then I multiplied by some factor here, right, some multiplier to get the 3.0 million. So I need to figure out what the factor or the multiplier is, right? So again, I start with 100%, but I went down 10.3%, right? So if I take 100 minus 10.3, that gives me what, 89.7%? So if we change this into a decimal, right, I would move the decimal over twice, we get 0.897. So that's what goes here. So then if I divide both sides by 0.897, I get x equals, so 3 divided by 0.897, I get 3.34 roughly. Right? Again, if we round to 2 decimal places, this would be million. Right? So 3.34 million people wanted a job in December of 2013, right? So wanted a job in December of 2013, right? And something else that I was thinking in my head but I didn't point out is that if I experience a % decrease, I would expect this value to be bigger than 3.0, right? So that's kind of a way we can check our answer. So this is above 3.0, which makes sense, right? So I started with some value, some bigger value, and went down, right? Where up here, right, we had a positive % increase, right? Or a positive % change, which is a % increase. So this x value, right, should be smaller than the 3.0, right? Because I started with some value and I went up, which gave me a larger number, right? So 2.81 million is smaller than 3.0, which is good, right? So it's kind of just like a common sense, like quantitative reasoning type of check that you can do, right? So then number 5, right, it says, what was the average mean duration of unemployment in weeks in December 2014? What was this in November 14, December 13? So here we're given duration of unemployment. We have in weeks, so the average and the median, right? We're also given the 1 month change and the 1 year change, right? So we're trying to find November 14. So for December, the average duration of unemployment was 32.8 weeks. Right? So if we want to figure out November 14, this had a 0.6% decrease, right? So going from November to December, so this is 14 and 14, we went down 0.06, or no, it's just 0.6%. Right, so we mark that as a negative. Right, so how can we calculate this, right? So again, I don't know November. I'm trying to figure that out, so that's x. And then I go through some change that goes down 0.6%, and then we arrive at 32.8. Right, we're trying to figure this out. So I'm going to do this one a little quicker, right? But you do it the same way as before. So we would take x times our multiplier. So if we take 100 minus 0.6, we get 99.4, right? So this would be 0.994 equals 32.8, right? So x is equal to 32.8 divided by 0.994. And if we round this to a couple of decimal places, right? We get 32.998, right? Oops, this would be weeks, right? This is my unit here. Right, so now we need to look at December of 2013. So going from December 13 to December 14, right? We started with X, and then we went down 10.9, right? The 1 year change, so down 10.9% to arrive at 32.8 weeks. Right? So again, we set this up the same way. I would take X times my factor, so 100% minus 10.9% gives you 89.1%. So then if I turn that into a decimal by dividing by 100, I get 0.891. And this is equal to 32.8 weeks. So then if I divide both sides by 0.891, I get 36.881, right? If we round to the nearest hundredth. So this is in weeks, right? So again, these values should be larger than 32.8, right? Because both of these experience a negative percentage change. So then part 6 says, why is the average duration of unemployment greater than the median duration, right? So this is one that we need to think about a little bit. So let me erase this print that we just did to make some room. So we know what mean and median is, right? But one thing that we want to consider is how much does like an outlier affect the mean versus the median, right? So let's say I have the data sample 1, 2, 3, 4, 5, right? Then the mean here, right, would be adding them all up and divide by 5, right? So 1 plus 2 plus 3 plus 4 plus 5, all divided by 5, and this gives me 3, right? Now the mean here, right, is, you know, put your orders from smallest to greatest and find the middle value. Well, that's 3, right? 3 here. So we put just 3, right? So let's look at the same data set. So 1, 2, 3, 4, 5. But instead of 5, maybe I'll make this 500, right? So this would definitely be an outlier in my data set, right? So what would this affect, the mean or the median, right? Whoops, and I said median, but I wrote down mean here, right? I apologize for that. This is median. Median. Right? So the mean, right, is the sum of the x's, right? So 1 plus 2 plus 3 plus 4 plus 500, all divided by 5, right? So that's what, 7, 7, 9, 10, 510, 510 divided by 5 gives you 102. So this mean is 102. So then the median would be the middle value, which is still 3, right? So you can see that just one number, one outlier, has a very, very much effect on the mean, right? So the mean went from 3 to 102 versus the median stayed the same, right? Now the median won't always stay the same, but the median is definitely less affected, right? So it says, why is the average duration of unemployment greater than the median duration, right? So when you have the mean, the average being much larger than the median, right? What you end up having is a positive skew, right? When your mean is bigger than your median, your data is shifted to the right, right? So what we could say here is the following, right? So I need to make some more space. So let me erase this. Right. So what I could say here is that the mean is pulled up by outliers. Some people have been unemployed for a very long time, right? Some people have been unemployed for a very long time, right? So something like that is get us along that line of thinking, right? So the number 7 says, in the demographics section, which is true and why? So we have part A, which is 4.8% of whites are unemployed, and part B, which is 4.8% of unemployed are white, right? So which one is correct? So if you look at this table, it says unemployment demographics. So we have white 4.8%, black 10.4%, Hispanic 6.5%, so forth, right? So when you have the unit at the top, it implies that all of these are the same unit, right? So all these are percent, right? So if you didn't notice that before, that's true, right? Or like here in this column, everything is points, so all of these are points, right? This first one is labeled as points, so all these are points, right? That's what's implied. So we need to try to figure out which one is true. So 4.8% of whites are unemployed. So does that seem to make sense to go along with this? So we can think about that, and then part B is 4.8% of unemployed are white. Right, so if we think about this for a moment, if part A is correct, right, what we're saying is you have group of all whites and 4.8% of them are unemployed, right? So that might be true, right? But let's look at part B. This implies that 4.8% of unemployed are white, right? So if we have a circle diagram, right, and if all the way around, if 100% is all of the unemployed, right? Then maybe, here 4.8% of the unemployed are white, right? And then, next we might have black, Hispanic, Asian, and so forth, and teenagers, right? But what do we know about everything all the way around? Well, this should add to 100%, right? So if we take 4.8 plus 10.4 plus 6.5 plus 4.2 plus 16.8, right? What you end up getting is what, 42.7, I think? 42.7. So this doesn't add up to 100%. So part B doesn't make sense, right? So I would say part A is true. Because if B were true, then 4.8 plus 10.4, right, and copy all those down, would add to 100%, right? So since they don't add to 100%, it makes sense that how to read this is if we look at only the whites, right, only the white population, then 4.8% of them are unemployed, right? So 4.8% is roughly 5, right? So basically what a way of thinking about this is if you had 100 white people in a room, you would on average estimate about 5 of them to be unemployed, right, that are in the room, right? Just to kind of get an idea for that in your head, right? So that's number 7, right? So then number 8, it says, which demographic group, including Asians, experienced the greatest one-year percentage decrease in unemployment? Note the chart gives you the total change. Right, so an important thing to keep in mind here is what's given in parentheses. It says, note the chart gives you total change, right? So let's think about this for a moment, right? So let me do just the white, right? We'll focus with white. So for the white population, right, if we look up at the table, so we're comparing what, December of 13 to December 14. So December 13 is what we don't know, right, X, but we changed, what, negative 1.2 points, right? I believe that's what it was, right? So if we go back up, for white, the one-year change was negative 1.2 points, right? So then this went to 4.8%, right? So then I would have X minus 1.2 percentage points, right, equals 4.8. So if I solve for X, X is equal to 6, right? So in December 13, we had 6%, right? But we were asked which one has the greatest percent decrease. So to find percent decrease, right, remember I'm going to take the new value minus the old divided by the old. Right? So to find this, I would take what, negative 1.2, right, is the new minus the old value, right, just that that change, and then divide it by the old amount, which was 6, right? So if I do that, I get what, negative 20%, right? So I'm just going to make a table up here. So for white, we got negative 20%, and then we need to do black, Hispanic, and teenager, right? So black, Hispanic, and teenager. Right? So let me do some erasing again. So let's do the black, right? So for the black, again, we're going December 13 to 14 still. We don't know what this amount was, right? But going from here to here, we had what, at minus 1.4, I believe. Yeah, minus 1.4 points. And that's percentage points, right? So again, we have to keep track and what's the difference between percent and percentage points. And then if we look at the table for black, in December of 14, there was a 10.4 percent, right? So this is 10.4%. So the equation I would have is X minus 1.4 equals 10.4. So then if I add 1.4 to both sides, I get what? X equals 11.8, right? So then to find the percent change, right? Percent change. Remember, I take the change, which we're told is negative 1.4, and divide by the original amount, which that's what we were doing, is trying to figure out, which is 11.8, right? The old amount. So if I take negative 1.4, and divide it by 11.8, I get about negative 11.9%, right? Negative 11.9%. So we can fill that in my table, right? So these show the percent decrease, right, for unemployment. So I need to erase these. We got to do it 2 more times, right? Hispanic and then teenagers. Right, so December 13 to December 14. So I go X, and the change was for Hispanics, we had a negative 1.9 change. And this is points, right? And then for Hispanics, we had 6.5% here. So X minus 1.9 equals 6.5, right? If we solve for X, we take 1.9 plus 6.5. You get 8.4. Right? So then to solve for this, right, we would take negative 1.9 divided by 8.4, right, to get the percent change. So negative 1.9 divided by 8.4. We get negative 22.6%, right? Negative 22.6%. And notice when we actually do this in the calculator, I'm getting it in decimal form, right? So then I have to convert that into a percent form, right, up here. All right, so then our last group is teenagers. So for teenagers, we went from X, and we had a minus 3.6 points change, and then we landed at 16.8. Right? So X would equal 16.8 plus 3.6. Right? So if we add that up, 16.8 plus 3.6, you get 20.4. So then to find the percent change, right, we would take negative 3.6 divided by 20.4. We get negative 17.6%, right? So you can easily see that Hispanics had the greatest 1 year percent decrease in unemployment, right? And why do you think, we said excluding Asians, right? If that wasn't obvious to you, if we look above, Asians were the only one that had a positive one year change, right? So obviously it wouldn't make sense if we're looking for who had the greatest decrease to even consider them, since they went up anyway, right? They would definitely wouldn't win the greatest percent decrease. So then number 9. Right, so it says in the unemployment by education level section, can you add the percentage for a high school and less than high school, and say 13.9% of the unemployment rate have at most a high school education, right? And the answer here is no, right? And the difference is when we looked at in number 7, right? So if we go back up to number 7, these are not percentages of unemployment, but percentages of each category that were unemployed, right? So when we were calculating these numbers, we were only looking at white. This is the percentage of whites in each category, right? But when we look here, we can't. All right, so let me correct myself, right? I lost my train of thought. So if we look at in number 7, right, it wouldn't make sense to add these percents together. We can't do that because there are a different number of white people than there are black in the population, right? So this is the percentage of whites, not a percentage of all of the unemployed, right? If these were percentages of all the unemployed, that means they have the same base, which means we could add them, right? So it all goes back to having the same base. So if we look here, we also cannot simply just add add these together, right? Because this is unemployed by education level, right? So what this means is we have the group of less than high school, right? 8.6% of them are unemployed, right? But then we have another category, different group of people. So this number isn't equal to the group before of just high school graduates, right? So let me maybe draw this out, right? So we have this group that's less than high school. And let's say there are, I don't know, 100 people in this category, right? And then over here, we have just the high school graduates. And let's say there are, I don't know, 10,000 people in here, right? So 8.6% of 100 is right, so 8.6% out of 100 would be roughly 9 people, right? 8.6 people, right? So in other words, if I have 100 people total for less than high school, that this statistic tells us that 8.6 of those people are unemployed, right? So about 9, right, roughly. Then over here, if we have 10,000 people in the high school, right? If I calculate 5.3 percent of 10,000, so 0.053 times 10,000, I get 530, right? So there would be 530 people in this category, right? So we can't simply just add these values together. It doesn't really make sense, right? Because if we wanted to find the percentage of people that are less than high school and high school that are unemployed, you'd have to take 8.6 plus 530, right? All divided by 100 plus a 10,000, right? So to find the percentage, you have to look at, well, what people are we considering, and then divide by the total number of people, right? So since these have different bases, right, where the bases are being 100 and 10,000, we can't simply just add these up, right? So this does not make sense. We can't do that, right? So this is no, right? And we can just say different bases, right? So then number 10, so this is the last question. It says, what is the growth factor for the 1-year change in average weekly earnings, right? So the average year change is plus 2.5%. So to find the growth factor, that would be 100% plus 2.5%, which would be 102.5%. So that would be 1.025, right? This is the growth factor, right? So it's just using a little different terms. If you remember above, when we talked about these, so where was that? Maybe I erased it. Well, here, actually. So I call this a multiplier, right? So this can be called a multiplier, or if it's a percent decrease, right, we can call it a decay factor, where if it's an increase, we can call it a growth factor, right? So it's just a different term you can use, and we're going to talk about those in more context later on, right? So growth factor, right, means we're growing, so that's a percent increase, right? So this would be the growth factor, right? All right, so that's the end of this worksheet, right? So if you need to review, like percentages and bases, right, I might do that, because that's the emphasis in this section, right? So whenever you change bases, right, that has a big effect on percentages, right? So remember, that was the whole idea why in number 9, why we couldn't just add these together, right? Because they're out of different people, right? So hopefully that helps understand that, right? So if you have questions, please email me. Thanks.